Hello and welcome to the Current Science and Technology podcast from the Museum of Science in Boston. I'm your host, Susan Heilman, and every week we bring you interviews with guest researchers and our museum staff covering science and technology in depth. This week we'll hear about blast detector badges for the military.
Soldiers face many dangers on the battlefield, including brain injury from explosions. Engineers and neurosurgeons from the University of Pennsylvania have created a blast badge that records exposure to explosive force by changing color. Here to talk about the blast badge is the museum's own Kareen Tate. Hi, Kareen.
Hi, Chris.
So what makes this blast badge important for soldiers in the battlefield?
Well, blast-induced mild traumatic brain injury has been called the signature wound from the wars in Iraq and Afghanistan. And it turns out that soldiers can suffer brain injuries not just from the blunt impact after an explosion, when that force of the impact kind of throws them and they hit something with a lot of force, but we're starting to realize that the shock waves from the blast itself can actually damage the brain.
So the blast doesn't actually have to hit the person on the head with some object. It can just be the air that hits them?
Exactly, or the frequency of this shock wave can actually damage the brain in certain ways. And with these mild traumatic brain injuries, they can be often difficult to detect. A soldier will seem to be fine after a blast, but there actually has been some kind of damage to the brain, and sometimes the injury can take a little while to progress. But probably even more dangerous is with repeated blast exposure, the damage can get worse and worse.
So every time that a soldier is exposed to a blast or a blast vibration, like you say, then that makes it more likely that they'll be injured further later. Is that what you mean?
Exactly. So scientists are realizing we need some kind of objective measure for the magnitude of the blast exposure over time, either in a single blast or with repeated blasts. One thing they're trying to do is create a detector that would let us know immediately if a soldier has been exposed to the level of blast that could potentially lead to a brain injury, or over repeated exposure. It wouldn't necessarily diagnose an injury, but it would let us know which soldiers really need further medical workup and which soldiers need to be watched to make sure that they don't have some kind of brain injury developing.
I see. So this blast badge that we're talking about today, is that a means or potential means for judging how hard a blast is?
Yes, and that's exactly what these researchers were trying to create, is a very simple, small badge that could be worn on a soldier's uniform or helmet. So it's very small, it requires no power source, it's lightweight and durable, and it gives an immediate read on the potential harm to the brain after a blast and the need for more medical attention. The idea is it could be easily interpreted even on the battlefield.
Wait, you mean it doesn't have any power source, so there's no batteries involved in this device?
There aren't. The way this badge works is it's made of a special nanostructured material. And this material changes color when it's exposed to a blast. And rather than relying on pigment or chemical composition to give it color, this material gets it from its structure, or the structure of the molecules. And the way it's structured is it's a 3D photonic crystal. And it's sculpted by lasers, and it's sculpted to have these pores, and these layers of pores are separated by columns. One way to think about it is kind of a nanoscale Swiss cheese that's separated by these columns. And when this is exposed to the pressure waves, the waves from these blasts, the columns collapse, and that change in structure gives it a different color. And the way it does that is these structures preferentially reflect different wavelengths of light. So when its structure changes, the wavelengths of light, it reflects change, and that gives it a different color. This phenomenon happens in nature, actually. It's called iridescence, and it's the same thing that butterfly wings get their color from. It's not actually from pigment, it's actually from the structure of the material.
That's really cool. So how accurate is the blast badge, or do they have any idea of how hard the blast is versus how much color is changed, or what way are they using this to measure the amount of force?
Well, right now, that's what the next steps in the studies are. They're trying to calibrate it to set an exact color change for a certain magnitude of blast. But they're well on their way. They think that within a year or two, they're going to have a product that's developed enough to be tested on the field.
One question that I have is, what happens to the badges out in the battlefield? I imagine that in wars and in battles, there's lots of commotion. And so what happens if there's some vibration or something, or if the soldier falls down or is hit? Is that going to make the badge change color too?
That's a great question, because if that was the case, it wouldn't be a very useful detector. But what's unique about this structure is it's incredibly durable to heat and cold and blunt physical impact. You could hit it with a hammer and it won't change. The structure really only collapses under the certain frequency you get of these shock waves after the blast. So that makes it really specific for its purpose and really useful just to detect blast, since it won't be set off by any other forces.
So it's not just the force of impact, but it's also the specific frequency that they're looking for.
That's right.
What are other uses for this device other than on the battlefield?
Well, there are other times we'd want to sense the magnitude of different blasts. It could be a detector that is put on structures or vehicles or other things that are around blasts that might suffer some kind of structural deficit after a blast. So while the initial usefulness is really for soldiers, it could be applied in a lot of other ways as well.
So when a soldier's on the battlefield and they've received some kind of brain injury, is there a way to tell if they've been hurt in that way? What's the way that a person is diagnosed with brain injury?
That's a good question, because actually mild traumatic brain injury is really difficult to detect and diagnose and treat. And actually, it does end up having really unique and long-lasting problems, so making sure you catch it early is important. But it's actually really difficult even to detect with conventional imaging of the brain. So one thing they're trying to do is figure out what level of blasts tend to result in mild traumatic brain injury, and this could be a tool that's really useful in determining who needs to be looked at closer to see if they actually do have these types of injuries. These types of injuries can be really debilitating, even though initially they seem to be fine after the blast. They found a lot of soldiers end up with headaches and depression, even severe cognitive deficits, personality changes, problems with their memory, sleep problems. These types of injuries really do have these long-lasting and debilitating effects.
Those sound like post-traumatic stress disorders, so maybe this would be a better way, or this would be a way to kind of have a better understanding of what happens to people when they come back from warfare.
Yeah, they actually have realized that these two disorders, these mild traumatic brain injuries and post-traumatic stress disorder, they often do get confused and misdiagnosed. So figuring out which soldiers have been exposed to blasts would be a good way to figure out that they might be more likely to have traumatic brain injury.
So this sounds like something that would be useful after a person comes back from a tour of duty. If you're in a football game and you have a concussion, then you can sit out for a play, but I don't know if that would work on a battlefield.
That's exactly right. And one thing they're really trying to avoid is sending soldiers back into battle or back on duty sooner than they're ready for, because the brain actually does need some time to heal from these types of injuries. And the more time they have to heal, the less likely they are to have these long-term symptoms.
Well, this is good news for soldiers who have dangerous jobs as it is. It sounds like we will soon be better able to treat soldiers who are returning from the battlefield by using this blast badge to better treat them. Thanks, Kareen.
Thanks, Chris.
That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.